Welcome back. Welcome to lecture 19 of Financial Mathematics for Actuaries. Today we are going to discuss one important concept, which is annuities that are payable on a quarterly basis or a monthly basis. So we in general say monthly. Okay, this is similar to what we have seen, that interest compounded monthly or interest compounded quarterly. So what if you start annuities payments on a monthly basis, which is typically the case, but so far whatever we considered in our lectures was related to payment once a year, and then we had this formula of present value of annuities, which was 1 minus v raised to n upon I, where I is the effective interest rate. But in reality, your mortgages are paid monthly, your car loans are paid monthly, you get dividends on a quarterly basis. So we need to adapt our formulas for this particular frequency of payment. That's what our goal today is. So by keeping that goal in mind, let us visualize what we are going to do today. So that is our today's roadmap. First, we will look at what exactly do you mean by visual monthly payment stream, okay, and how it relates with our annual payment scheme. Once we have discussed that and we have derived an efficient formula to do that, we will introduce a notation which is AN bracketed M, A angle N super M. So this notation we will use for monthly payments or calculation of monthly annuities. Then we will actually look at how to memorize this formula using denominator slot machine, and then finally the practical use of it, which will be mastering calculator strokes. So in this case, payments per year, if it is on a monthly basis, will be 12, if it is on the quarterly basis, will be 4. So how to use your calculator so that it will reflect that particular need. As usual, the reference mapping of these contents goes to Browerman section 2.2, Chan and Say sections 2.5 and 2.7. We recommend readers to go through these sections in order to have elaborate understanding on this topic. Okay, so let us take our first agenda, which is visualizing a monthly payment stream. So how to visualize? So here is 1 unit of payment that you are supposed to make or get. So this is the 1 unit which should be paid at the year end. But in general, what you are doing, you are actually paying them on a monthly basis. So what you will do, you will not pay this into full, but what you will do, you will slice it in 12 payments. Okay, so that slicing will happen, and if once that slicing happens, it will look something like this. Okay, so it's 1 by 12th of a payment will be made in the first month, 1 by 12th of a payment will be made in the second month, and over the year I am making 12 payments of amount 1 by 12th of the original amount. Correct? So this is the idea. So what we are doing is we are splitting a single payment into monthly installments of 1 by 12. Correct? Now you may ask me a question, if I use time value of money, all these payments will have different values. How will I account for that? We will address that question. Okay. So now let us come to our notation, which we are denoting A N M. This is the notation that we are denoting. Let us understand this notation. We are already familiar with the notation A angle N, okay, which denotes the annuity immediate, which is paid at the end of the period, immediately after end of the period on a yearly basis. Now it is the superscript that is topped onto it is bracket M. So it denotes the compounding frequency. So what this denotes is present value of annuity paying a total of 1 per year. Paid installments are paid at each mth of the year, and the amount is 1 by m. Okay. So, therefore, the total number of installments are n into m, and each payment is of amount, because it is a total of 1 unit. So, divided by m, 1 by m. What is a frequency? If I am dividing a year into m equal parts, then the frequency will be 1 by m. Okay. So, what does it mean to say this? Let us take one example. That means I am saying, if I pay $100 per month, the total annual payment is $1200. Okay, and the present value of that will be calculated using this formula. Is it understandable? I will repeat again. If I am paying $100 per month, then this is equivalent to 1 by 12. Okay, then together I have $1200 in a year, and that 1200 is multiplied by this single unit that we are denoting with a notation A angle N M, that M is 12 now. Okay, that should be very clear now. So, this is what we meant, and now we will derive this formula or see the intuition behind this formula for better clarity. Let us look at this formula and design our denominator slot machine that we have proposed. So, whenever you are computing present value, the present value is inevitably sum of it is sum of a geometric series, correct. So, we will keep that in mind, and therefore, when we started with present value of annuities, we had a formula of PV equal to 1 minus V raised to n, where V can be associated with interest rate as V is equal to 1 upon 1 plus I. And then there was a denominator for which we have to do some calculation, and it turned out that 1 plus I minus 1 plus I minus 1 was the denominator, and it turned out to be I. This is when it was annual immediate annuity which is immediate and computed annual basis. Okay. Then we saw another interesting case where annuity due was there, and it was supposed to start at the beginning of the month, and therefore the discount factor was replaced with I. However, we noticed that this D need not be considered. We will work with the present value of annuity and multiply it with 1 plus I. That was our understanding, and that was okay. Now, when it comes to our monthly payments or monthly payments, how will this change? So, as you notice, there is only one subtle difference, that this denominator is changing. So, what we will do in this case is we will put the nominal interest rate as our denominator of monthly, because you see the compounding is actually happening over a yearly period, and if you take this nominal interest rate, it will take into account that compounding which is happening. Okay. So, this is the key insight. So, what happens is the numerator will remain as it is, however, the denominator will go to whatever compounding that you are doing. So, I am. So, it in a way I am saying my present value is influenced by the compounding through the denominator. Compounding frequency influences the denominator, not the numerator. Okay. If this is clear, then you do not have to memorize any formula. If you know how to compute annuity, you know how to compute annuity monthly. Okay. After that, suppose now this is immediate annuity. If I want to replace this with annuity due monthly, what will change? This IM will be replaced by DM, nothing else. So, the denominator will adjust for the frequency and the type as well. The two types of annuity, immediate and due, both are taken care of by the denominator. Okay. So, if it is due, as the name suggests, that D, it will be denominator will be DM, and if it is immediate, as the name suggests that immediate I, it will be IM. This is how we will remember this. It's very simple, and we have our denominator slot machine always active. Okay. So now we have understood how to compute present value under various compounding schemes. Let us take one example and try our hand on this problem. Okay. So right now the problem is present value of $100 at end of each month for 5 years is what I need to compute. What I need? I need the annual interest rate, or the interest, any interest rate. 6% is the annual interest rate. So how many years are there? 5 years are there. And do I know the how to compute present value? Yes, I do know, right? So what I know, if I want to compute annuity of 5 years, is this immediate or due? It's immediate. Okay. So it's A phi with that angle, and frequency period is 12 because this $100 are paid every month. Okay. What will this be? Okay. Remember your slot machine. This frequency should be adjusted to that. Okay. So that is where I get 1 minus V raised to n upon IM. What are the things that I know? I have been given effective interest rate 6%. Okay. Then V is 1 upon 1 plus I. This we have already seen. V is 1 upon 1 plus I. So I will simply use that. So this becomes 1 minus 1.06 raised to minus n. I have not yet said what is n, right? And this will be I m, which is I 12. Let us look at what is n. Because this is effective annual interest rate that I am computing, this will be 5 years, right? So this n will replace 5. Okay. So I have the formula for annuity. What are the things I don't know? I don't know what is I12. That's all. Okay. Then I want to compute the present value. So to compute this present value, what do I need to know? I need to multiply the amount, right? So 100 paid at each month. The computation is done annually. So 100 summed over a year. That's what I will write, which is 1200 into whatever this A angle phi 12 is. Okay. So this is how I will set up the equation. So I have converted the total annual payment to 1200, and then I have set it in the present value equation or equation of value. So this is step 1, where I have converted 1200. I have figured out what is A phi 12 and I substituted it. Okay. What do I don't know? I12. How will I find it? So again, recollect what we have done. What I need is just 1 plus I, right? And how will I connect it with 12 payments? 1 plus IM by M raised to M. Right? So this is the basic key finding that we have. This we called as a bridge equation, right? So essentially what I am saying, 1.06 is equal to 1 plus I12 by 12 raised to 12, correct. So if I can solve this, I will be able to get it. So let us solve this. That is our step 3. So I have solved it, and it's simply taking raised to the power 1 by 12. I got this answer, and then some linear some algebra that I did, and I got the answer to be 0.05841. So that means the compounding, or the nominal compounding that I require is 5.841. Given an interest of 5.841, that is compounded monthly, I get this. So what is the next step? Next step is calculating the present value. So I will feed in that value into this and I will solve for it. The answer is 5192.38. That is the present value of whatever investment I am going to do. So let us look at the calculator steps. I first warn you about this payment per year hazard. Typically when you are using BA2 plus calculator, this is set to 1. So what you need to do is, you need to first go into the calculator, go to second, press I by Y, and then see that is P by Y equal to will be written. If it is 1, now set it to 12. Similarly, you go to second, then you go to icon V, then press the down arrow twice, you will see the screen of C by Y. Check what it is. If it is not a number, then you put it as a 12. Okay. So here the total number of payments, if you look at it, them on a yearly basis, we are making 12 payments. We are making payments for 5 years. So 5 into 12, 60 payments. So N is equal to 60. Then interest per year, we will put the nominal interest rate figure, which is 5.841. Okay. And then you have to put in the PMT, the payments per month. In this case, it was 100. Right, payments per month was 100. So you put that as 100 and then you compute the present value. You should get the answer that you are seeing on the screen. Okay. One more reminder, P by Y is 12. You go back and reset it to 1. Don't forget to do this. Okay. Otherwise, if you are solving some other problem which has the annual payments, you will land up in trouble. So you always do this. Now it's your time to check the skill that we have learned for yourself. So here is my next problem. You are supposed to borrow $20,000 and pay 400 per month with a nominal rate. Now nominal rate 6% compounded monthly. You are asked to find the unknown value of N, how many months to pay off. So pause this video, use the annuities formula, do it by your hand and do it by your calculator, and come back and we will walk through the solution. Okay. So let us solve this problem. Let us look at the solution. First, I know the present value is 20,000. The cash flow going out is 400 per month. I by Y, which is nominal, given to be 6%. You also put P by Y to be equal to 12. Okay. So if you set all these things, you need to then just say compute N, and that will give me the answer of 57.68 months. As usual, we have already learnt in earlier videos how to deal with this case. There can be a drop payment or there can be a balloon payment. Generally, the preferred methodology is drop payment. So there will be 57 full payments of $400 and one partial payment we call as a drop payment at that month. So what is happening here is, we are essentially having 57 full blocks and one partial block of 0.68 will be delivered on month 58. This is not how much to pay is not asked in this question, so we are not computing, but always remember this 58th month will come with some interest associated with the block that you have unpaid at the end of 57th month. So this you should always remember. If the question asks, you have to multiply by 1 plus that compounding frequency, IM by 12. That should be the case, right? Okay. So we have understood this completely. Now let us, so far what we have done is, we have seen the connection with present value. Now we need to understand the connection with future value. What if we want to understand what is a future value? That is the next relationship. So in a similar manner as we discussed A angle NM, there is associated concept S angle NM. Okay, what should be the connection? As we have seen visually in the last particular video, that this is nothing but shifting by n time periods forward, right? So when I am shifting by n time period forward, it will be multiplied by 1 plus I raised to n, nothing else, correct. So now when I multiply this with 1 plus I raised to n, you can also deliberate on this a n m was 1 minus v raised to n into 1 plus I raised to n upon I m. This was there, right. So now this v is what, 1 upon 1 plus I. So it is very simple to see, this actually converts into 1 plus I raised to n minus 1 upon Im, very simple, right. So this is how we will get the relation. So you do not really have to memorize this relation. If you are asked for a future value, look at how many periods and just multiply by 1 plus I raised to n. Okay. No, one note that we have to observe is this I that I am writing is the effective interest rate, because this effective interest rate is annual interest rate which will remain annual. Okay. We do not have to worry about it. Okay. So the numerator as it is multiplied by 1 plus I raised to n is giving you the connection with future values. So that is true for all other calculations also. So we have learned exact relation when we are having annuities which are paid monthly. Okay. So let us summarize what we have done. We have used the notation AM, which means M payments M times, which means payments M times a year. We replaced the denominator I with IM, and then we saw this calculator trick where P by Y was set to be equal to M, and you have to set it to 1 after you have done all the calculations. Then the result which was there in the decimal places in one of the examples, 0.68, okay, which will imply the drop payment, and we will do the drop payment on the 58th month in that case with interest. Okay. So that is what we did in today's lecture. Lecture 20 will be most interesting lecture. This is the lecture on retirement planning. See you in the next lecture.